Welcome to our database design and implementation masterclass, tailored specifically for beginners in mind. I'm Amar Morrison, a SQL Server specialist with almost a decade of experience in the field. Over the years, I've managed databases such as SQL Server, Oracle, and Postgres, both on-premise and in the cloud. Whether you are an enthusiastic student diving into the world of data management or a professional aiming to broaden your skill set, this course is designed to cater to individuals with little to no prior experience in database design. So this course is ideal for students pursuing degrees in computer science, information technology, or any other related fields. Or if you're looking to break into tech and you're looking to pivot into roles like data analysts, database administrators, or software development, then this course is ideal for you. It sets the foundation for database administration and data analytics. No matter your background or experience level, if you're intrigued by the world of data and databases and eager to learn how to design efficient database systems, this course is your starting point. Join us as we embark on an educational journey aimed at demystifying database design for beginners, empowering you to create well-organized and optimized databases that power the technological landscape. Let's dive in and unravel the mysteries of database design. So in this section, guys, we're going to be learning about file-based systems, how it was used in the past, what is a database, and what are the different types of database, and emerging technologies, the way in which computers manage data over the last few decades. Today's users take for granted the many benefits found in database systems. However, it wasn't that long ago that computers relied on much less elegant and costly approach to data management called file-based system. Now, one way to keep information on a computer is to store it in permanent files. A computer system has a number of application programs. Now, each of them is designed to manipulate data files. These applications are programs that have been written at the request of users within the organization. Now, new applications are added to the system as the need arises, right? Consider a traditional banking system that uses file-based system to manage the organization's data, as you can see on the screen. As we can see, there are different departments in the bank. Each has its own applications that manage and manipulate different data files. For the banking systems, the program may use to debit or credit an account, find the balance of an account, add new mortgage loan, or even add a new car note. Now, like everything else, there are some disadvantages of the file-based approach. One of the main ones is data redundancy. Now, within an organization, files and applications are created by different software engineers for various departments over long periods of time. Now, this can lead to data redundancy, right? Now, this is a situation that occurs in the database when a field needs to be updated in more than one table. Now, this practice can lead to several problems such as inconsistency in the data format. You also have data inconsistency, right? A situation where various copies of the same data are conflicting. So it's a waste of storage and space and duplicate effort. Another big problem is data isolation. Now, what is data isolation? This is a property that determines when and how changes made by one becomes visible to other concurrent users of the system. Now, this issue occurs in concurrency situations, right? This is a problem because it is difficult for new applications to retrieve the appropriate data when it might be stored in various files. A big issue here is that we have data integrity problems, right? So problems with data integrity is another disadvantage of using the file-based system. So this basically refers to the maintenance and assurance that the data in the database are correct and consistent. So end users or consumers of the data need to be sure that they can trust the data that they are getting from the database. And with the file-based system, it is very difficult to make changes to the application program in order to enforce new constraints. You also have security problems, right? This can be a problem for the file-based approach because there are constraints regarding accessing privileges. You also have application requirements that are added to the system in other manner so it is difficult to enforce constraints. Now also with file-based system, you have to understand that it is difficult to detect data that has been tampered with or corrupted, right? So those are just a few challenges with file-based system. Another one is concurrency access. Now, this is the ability of the database to allow multiple users to access the same record without adversely affecting the transaction processing. A file-based system must manage or prevent concurrency by the application programs. Now, typically in file-based system, when an application opens a file, that file is locked. This means that no one else can access that file at the same time. Now, this can be very problematic. So let's say we have 100 users trying to access the same file. Now, unless that file is released by the user, the other 99 users who are trying to access that file has to wait. Now, in database systems, concurrency is managed as allowing multiple users to access the same record. Now, this is an important difference between database and file-based systems. In today's world, there are hardly any application that doesn't use a modern database. The difficulties that arise from using file-based systems have prompted the development of a new approach in managing large amounts of organizational information called the database approach. Databases and database technology play an important role in most areas where computers are used. So from business, education, right on to medicine, today databases are impacting these areas. So in order to understand the fundamental concepts of database systems, we're going to be introducing some basic concepts in this area, right? So like I've mentioned earlier, almost every application today uses a database. So you almost cannot do anything on the internet that does not have a database behind it. So literally, everybody uses a database in some way or another. So even if we want to look at it in a more simpler way, right? Like just think about it, even if it's just to store information about friends or family, that data might be written down or stored in a computer by using a word processing program, or it is saved in a spreadsheet. One of the best ways to store data is to use a database management software. This is a powerful software tool that allows you to store and manipulate data and retrieve it in a variety of ways. Most companies keep track of their customers' information by storing it in a database. This data may include customers, employees, products, orders, or anything else that assists them with daily business operations. In the next lecture, we'll be taking a look at what is a database. In this digital age, data plays a crucial role in various aspects of our lives, and databases are fundamental to managing and organizing this data effectively. In this lecture, we will explore the concept of databases, their importance, as well as some of the properties of a database. Now, what is a database? A database is a structured collection of data that is organized in a way that allows for efficient storage, retrieval, and manipulation of data. Databases serve as a repository for data, making it easier to manage, access, and analyze information. There are several properties of a database. Typically, it represents some aspect of the real world or a collection of data elements representing real world information. A database is often logical, coherent, and internally consistent. A database is designed, built, and populated with data for a specific purpose. Each data is typically stored in a field, right? A combination of fields make up a table. So now let's look at a real example of a database. So here I am connected to a SQL server. Don't worry too much about this, right? Later on you'll learn more about it in this course. And these are several databases. So this is the AdventureX database, which is from Microsoft. So I'm going to expand. I'm going to go to tables, right? And these are the tables that store data. Now remember, a data is stored in a field. So if I right click on one of these tables, select edit top 200 rows, So all of this you're looking at is called a table, and this is the address table. Now a single cell is called a field. Now going down is called a column, and going across is called a row. So everything in a row is related. So if you're supposed to look back at the properties just I had mentioned, for example, a combination of fields make up a table, you'll see that that is exactly what is taking place here. So in the next lecture, guys, we're going to be looking at the types of databases. In this lecture, we're going to be taking a look at the different types of databases. The three general database types: you have relational database, non-relational database or no SQL, and 3, you have object-oriented database. Difference between models is the way information looks inside the database. So consequently, each model type has a different management system and data relationships. Now, the relational database is the most extensively used, as well as it is the oldest type of database. Now, there are 3 critical components of a relational database. You have tables, which is an entity type with relations. You have rows, which are the records in the table or the instance of an entity. And then you have columns. This is the value attributes of the instance. Now, a relational database provides a set of data rows in response to a query. So this is just the theory aspects, guys. So you will see this later on in this course when we go more into the practical stuff. You'll understand it much better, right? But as you get familiar with the databases, you'll get more accustomed to these terms. Now, a common language which is normally used to access this data is called SQL, which stands for Structured Query Language, right? So you use this to interact with your data. Now, the main features of relational database is that they are asset compliant. This means that the database retains its integrity while performing transactions. You also have a range of data types. This provides the capability to store data as well as carry out complex queries. Collaborative or concurrency, right? Multiple users can access the database and work on the same project. It is also secure. Access is limited or restricted through user permissions. They are often stable, that they are well understood and well documented. Now you may be wondering, what are relational databases used for? So there are many use cases and I'll be just giving you a few of them, right? So one of the main one is online transaction systems. The database supports many users as well as frequent queries needed in online transaction. You also have IoT. Relational databases are lightweight and have processing power needed for edge computing. You also have data warehouses. Now, the critical component of the data warehouse architecture is storage. Relational databases are easily integrated and optimized for massive queries from multiple sources. So, a data warehouse is a type of database that is normally used for reporting with an organization. So it is not frequently updated like the online transaction systems database. Now, there are countless commercial as well as open source databases. So the top 10 most popular relational databases are Oracle, MySQL, SQL Server, PostgreSQL, IBM DB2, SQLite or SQLite, Microsoft Access, MariaDB, and Microsoft Azure SQL Database. If you're completely new to database administration and you want to go deeper in one of these fields, you can check out my additional courses. So another type of database is the non-relational database, or typically referred to as NoSQL. Now, this is a type of database model that stores data differently from relational databases. So instead of tables, non-relational databases models relationship between data in an alternative way. So there are basically 4 types of non-relational database types. So you have column-based, you have key-value-based, you have graph, and document. So this is basically how the data is stored within the database. So there are some key features of the NoSQL databases that you need to be aware of, right? So handling structured data, semi-structured data, and unstructured data is a breeze with no relational database types. They are scalable and responsive. Massive data storage scales well with on-demand servers and provide quick query responses. You have multiple data structures, right? So the scalability of cloud computing architecture incorporates perfectly with non-relational databases. So they are typically used for real-time systems, right? And they are becoming really popular for go-to databases for mobile apps. Some of the most popular NoSQL databases are MongoDB, Redis, Cassandra, HBase, Neo4j, Oracle NoSQL, CouchDB, DynamoDB, RavenDB, and there are a bunch of others. Typically, each of the cloud platforms these days have their own NoSQL database. Now, last but not least is the object database. Now, this is the least popular of all the databases. So the object-oriented database combines object-oriented programming concept with database capabilities. Now, if you're not familiar with object-oriented programming, it is an approach of programming, right? It is an approach of programming based on conceptual objects and classes. An object is a reusable blueprint for a physical or non-physical entity with descriptive and functional elements. I hope this doesn't sound too technical, right? Don't worry about it too much now. Maybe in your lifetime you will not be using an object-oriented database, right? I've never came across any, but it's good that you are still aware of it. So just to name a few popular object-oriented databases, you have DB4O, Object Store, Matisse, and ObjectDB. So by now you should get a clear idea of the different types of databases that are available and which one to use. Now in most cases you'll be using relational databases. It's important that you know about the NoSQL databases. You may just run into one that you have to manage. So like everything else, database technology changes over time, right? So there are several emerging technologies that you need to be aware of. So you have new SQL databases. So these databases combine the benefit of traditional SQL databases with the scalability and performance of NoSQL databases. Some notable examples include Google Spanner and CockroachDB. You also have time series databases. Time series databases such as InfluxDB and Prometheus are designed for handling and analyzing timestamp data. They are particularly valuable for applications in IoT, monitoring, and financial analysis. You also have graph databases like Amazon Neptune, which is ideal for applications that require complex relation modeling such as social networks, recommendation engines, and fraud detection systems. And you also have blockchain databases, right? Blockchain technology is not limited to cryptocurrency. It is increasingly being used to create secure, transparent databases, especially in industries like finance, supply chain, and healthcare. A very important one that you need to be aware of is serverless databases. So you have serverless databases such as AWS Aurora Serverless. This allows you to scale your database capacity automatically, making them cost-effective and low-maintenance choice for a certain application. So this is just to name a few of the emerging technology databases. So in the next lecture, we're going to have a quick recap on what we would have learned so far. So to summarize guys, in this module, you would have learned about the file system database and how they are useful today, and some of the emerging technologies that you can look out for. In the next section, we'll be taking a look at entity relationship diagrams. In this section, you learn what is an ERD diagram, you learn about conceptual modeling, entities, attributes, relationships, cardinality, and participation. all of which are important for designing a database. In the next lecture, we're going to be taking a look at what is an ERD diagram. So in this lesson, guys, we're going to be talking about entity relationship diagram, also known as ERD. So what is an ERD? Now, an ERD is a type of diagram that shows how different entities, for example, people, customer, and other objects relate to each other in an application or database. They are typically used to design and model relational databases, and they show the logical structure of the database. They are made up of many different components, including entities, relationships, and attributes. Now, entities are things that have data stored about them, such as physical objects, concepts, or events. Now, relationships define how entities are related to each other, and they can be derived from verbs when speaking about a database or a set of entities. Now, attributes are properties of an entity or something that can be used to describe an entity. So, for example, an entity can be a car. Now, a car has a color, which is an attribute. It has a chassis number, which is an attribute, right? And it has a model, which is an attribute. So you can think of things like that. Anything that describe the entity or properties of the entity. So what I want you to do now is think about few entities, right? Write them down and then try and come up with some attributes for those entities. Now, it's important to note that ERDs use specific set of symbols such as shapes and arrows to depict the system and database. So here we have a simple ERD diagram of a supplier company, right? So these are the entities, and here we have the lines, which are the relationships. So these lines show how each entity relates to each other. In the next lecture, we're going to be taking a look at conceptual modeling and attributes. So in the previous lecture, we looked at ERD, which is a type of database modeling. So what the database modeling or ER modeling helps you to do is that it helps you to analyze data requirements systematically to produce a well-designed database. So it's considered best practice to complete ERD modeling before you implement your database. This really allows the designer to get a big picture of the system they are working on. So in other words, it is the blueprint for your database, and this model captures the relationships that exist between different data elements. So what are some of the reasons why you want to use an ERD diagram? It helps you to determine terms related to entity relationship modeling, right? It also provides a preview of how all your tables should connect. It helps to describe entities, attributes, and relationships. ER diagrams are translatable into relational tables, which allows you to build your database more quickly. It also allows you to communicate the logical structure of the database to users. So as mentioned in the previous lecture, a ER model has three basic components: entities, attributes, and relationships. In the upcoming lectures, we're going to be taking a detailed look at each of these. In this lecture, we're going to be taking a look at entities. So in the lecture on ERD, we had spoke briefly about entities, and I had asked you to think about a couple entities and write down their attributes. Now, if you're extremely new to databases, which I think you are, then you may be still wondering and may not have come up with a few entities, right? So when you think about entities, I want you to think of items from the real world that are capable of unique existence, right? That is, it can be distinguished from the other. So if you think about person, you can distinguish one person from the other. There will be something that is unique about them, whether their first name, their last name, their ID number, their eye color, there will be something different. You can also think about entities as anything and which information can be stored or recorded in the database about it. So again, if you think about a car, you can store information about a car in a database. If you think about a school, you can store information about a school in a database. Now on the ER diagram, they are typically represented by a box labeled with the name of the entity. So for example, if you have school, you'll have the name of a school in a box. If it's a student, then you'll have the name of a student in a box. Or if it's a person, then you'll have the name of a person in a box. So by now, you should have an excellent understanding of what entities are. So again, go ahead, think about few entities and write them down. So guys, there are two types of entities. You have the weak entities and you have the strong entities. So think about it for a minute and see what would come to your mind for a weak entity and a strong entity. So I'm going to give you a few seconds to think about it. So guys, the weak entities are the entities in the database that do not have a primary key attribute of their own. They rely on the related entity known as the identifying or parent entity to provide part or all of their primary key. So typically, they are dependent on the identifying entity. So a weak entity cannot be uniquely identified by its own attribute. Instead, it depends on the existence of a related entity known as the identifying entity to create a composite primary key. So the primary key of a weak entity is typically a composite key, right? It comprises of the primary key of the identifying entity. They often have one-to-many relationships with their identifying entity. This relationship signifies that one instance of the identifying entity can have multiple instances of the weak entity associated with it. They are typically denoted with a rectangle with an outer rectangle around it, right? So if you look on your screen now, it's a simple ER diagram where a customer borrows a loan. So if you look at the weak entity, you can clearly distinguish it from the strong entity because it has a rectangle around it, right? So anywhere you see this on an ER diagram, it's a weak entity. So a loan can't exist without a customer, but a customer can exist without a loan. So guys, the strong entities are the entities in the database that have a unique identifier or a primary key attribute of their own. They exist independently and do not rely on any other entity for identification within the database. Now there are some key features that you really need to note, right? So the first one is the independent identity. That is the unique key or the primary key. So strong entities have attributes that uniquely identify each instance or record within the entity. So they have no dependency on other entities. So unlike weak entities, strong entities do not rely on any other entity for their existence or identity. Now think of a person as a person can exist without any other entity or parties involved, right? They can also have relationships. That means they can participate in relationships with other entities. So the simple ERD you're seeing on your screen now, right? Where you have a customer borrows a loan. You can see that customer is a strong entity because it can exist by itself and doesn't need a loan. So this is typically denoted by a solid box. So the strong entities are the fundamental building blocks within the database schema and often serve as the core element around which relationships and connections with other entities are established. They are typically represented in an entity relationship diagram by a rectangle with single borders. So in the next lecture, we're going to be taking a look at attributes. In this lesson, we're going to be exploring another fundamental concept in database design called attributes. Now, in the realm of databases, attributes play a crucial role in defining the characteristics of an entity and their relationships. Understanding attributes is essential for creating a well-organized, efficient, and meaningful databases. Now, an attribute is a property or characteristic of an entity. In simple terms, attributes describe the features that define an entity and help distinguish it from other entities within the database. These attributes can be thought of as a building block that contribute to the richness of the data within the database. There are 5 types of attributes that you need to be aware of, right? You have a single valued attribute. This attribute is atomic and it holds only one value. So on the ER diagram, it's denoted looking like a little oval shape, if that's what you want to call it, with the name of the attribute inside of it. So a single value attribute would be like your first name and your last name. Now you have the multi-valued attribute. So as the name suggests, it may store several values. So an example of this would be multiple emails and multiple phone numbers. So on the ERD, this is denoted by like an oval shape with another oval shape inside of it with the name of the attribute. You also have the derived attribute. So the derived attributes are the ones that can be calculated using another attribute. So age would be an example of a derived attribute because you can use the date of birth to derive the age. So you would necessarily want to ask somebody to enter their age whenever they are, say, signing up for a website. You ask them for their date of birth. So as each year passes, you really need to recalculate that age. So instead of going and updating the person's age each time, you just calculate the date of birth. An oval shape drawn from broken lines. Next you have the composite attributes. These are the attributes that can be divided into subparts, right? Each representing one or more detailed characteristics. For instance, address attribute in a customer entity. This can be a composite with subparts like street, city, and zip code. You also have the unique identifier. Now this attribute is used to uniquely identify one attribute from another, and it is non-repeating. So this will be like another oval shape again, right? But this time the name of the attribute is underlined. So this denotes that it is a unique identifier, typically known as a primary key. So if you think of like a student table, within a student table you would normally have like a student ID. The ID uniquely identifies a student, right? Because you can have 2 students with the same first and last name. So this is where the unique identifier comes in handy. So here we have a simple ERD diagram containing just an employee entity. So this is the name of our entity, which is the employee. Then we have the name attribute and the employee ID. Now the employee ID is used to uniquely identify the employees. Therefore, it has an underline under it. Here we have address, which is a composite attribute, because the address can be then further be broken down into street name, city, district name, in some cases zip code and state, right? You also have date of joining, and you have work experience, which is a derived attribute. Now the work experience can be derived from the date of joining. Then you have phone number, which is a multi-valued attribute. Now if you look carefully, the work experience is denoted by broken lines. And you have the phone number, which is a multi-valued attribute because an employee can have multiple phone numbers. So they could have a personal phone number as well as a work phone number. So it's denoted by this little oval shape and the outer oval shape with the name of the attribute inside of it. In the next lecture, we're going to be taking a look at relationships. In this lesson, guys, we're going to be talking about database relationships. They are fundamental in organizing and connecting data within a database. So what they do is that they really define how different tables relate to each other. So you can consider it as the interaction between 2 entities or tables. It is typically represented by means of a diamond connecting entities participating in a relationship. So for the attributes, you have ovals, and for the relationships, it's a diamond. Now there are 3 types of relationships, right? And these are often referred to as cardinality. So you have a one-to-one relationship, a one-to-many relationship, and a many-to-many relationship. Before we look at the types of relationships in detail, we need to understand that entities can participate in relationship in different types of ways, and this is known as the degree of the relationship. So you have the unary relationship, right? In the unary relationship, an entity is related to itself. This relationship occurs within a single entity. For instance, consider an employee entity, where the employee is the manager for other employees within the same entity. We also have the binary relationship. So this is the most common type of relationship where you have two entities involved. For example, in a database for a school, right, you might have a binary relationship between students and courses, right? So you can easily visualize this one, right? A teacher teaches courses, right? So you could have a relationship like teacher teach student. So that would be an example of a relationship, and that would be represented in the diamond on the ERD. You may have a relationship between students and courses, right? So each student can enroll in multiple courses, and each course can have multiple students. Now you also have ternary relationship. So this involves three entities. It's less common but occurs when there is simultaneous relationship between three entities. For instance, consider a scenario where a doctor prescribes a medication to a patient. So the doctor is an entity, the medication is an entity, and the patient is an entity. So in this case, the prescription would involve all three entities. This degree helps you to understand the complexity and the nature of the relationship within the database. Relationship, an entity can participate in it optionally or mandatorily. So as the name option suggests, right, when there is a relationship, an entity, right, doesn't have to participate. Now, entities may participate in a relationship mandatorily or optionally. Now, the mandatory participation can be also considered as total participation. So in the mandatory participation, every entity in one table must be associated with at least one entity in the related table. Now let me say that again. Every entity in one table must be associated with at least one entity in the related table. So it means that for a relationship to exist between two tables, each record in the primary table must have a corresponding record in the related table. Now let me give you a simple example of this, right? So person have an address. So when you insert a person record, you must insert a related address with that person. So that would be an example of a mandatory participation. Now you can also consider a relationship between a department table and an employee table. So if the business rule dictates that every employee must belong to a department, then the participation of the employees in the department is mandatory or total. In this example again, the employee record must be associated with a department. Now, optional participation, also known as partial participation, allows for some entity in the table to not be associated with any entities in the related table. It means that certain records in the table may or may not have a related record in the related table. So, in a scenario where you have an order table, a customer table, some orders can exist without being linked to any specific customer. For example, you could have online anonymous orders or guest orders. Then the participation of the orders in the customer table is optional or partial. So basically, some orders may not have a corresponding customer. So now let's backtrack a little and look at one-to-one relationship. In a one-to-one relationship, one record in a table is related to only one record in another table, and vice versa. Now, this is not very common in databases due to its limited use cases. For example, a table containing employee information might have one-to-one relationship with a table storing sensitive personal details. So you could also think of a situation where, just for example's sake, you have one customer can own only one bike. One bike can be owned by one customer. One person can own a truck, and one truck can be owned by one person. Now, both of these are hypothetical scenarios because, as you know, a customer can have multiple cars and multiple bikes. In a company, there can be a business rule that say, hey, the employee can only be assigned one company car at a time. So this is typically denoted by a diamond with the name of the relationship and the relationship arrow diagrams. Now note carefully the type of arrowheads that is used in the one-to-one relationship. They are ending with an arrow. So the next relationship we have is the one-to-many relationship. Now, this is the most common type of relationship where the record in the table is related to multiple records in another table. So in this example, we have one person or customer can own many trucks. However, one truck can be owned by one person. Now, if you look carefully on the customer end where you have the arrow pointing, it has an ending. This is indicating that a truck can be owned by only one customer. Now when you look to the end of the truck, there is no arrow. This is indicating that the customer can own many trucks. In the many-to-many relationship, an entity can be related to another entity many times and vice versa. For example, a customer can own many houses and many houses can be owned by many customers. Now, what do I mean by this? You can have joint ownership when it comes on to houses. So it is denoted by a diamond, but this time there is no arrow on the relationship line. Now for the optional participation relationship, it means that if there is an instance of an entity, it can exist by itself and not participate in any other relationship. It is denoted by a diamond, the name of the relationship, and two lines without any arrows. For example, customer owns a truck relationship. So you have the customer, then you have the relationship which is owned, and then you have the entity which is car. You can have a car without having a customer. Now for the mandatory relationships, once an entity exists, it must participate in a relationship. Now this type of relationship is denoted by a double line. So for example, if you think about a scenario in a bank, right? You cannot have a loan without a customer. So once a loan exists, it must be participating in a relationship. So now let's take another look at the types of relationships. First, we're going to take a look at the unary relationship. Now guys, I want you to understand that I did this lecture like this in a repetitive manner because I remember exactly when I was learning database design for the first time, these things felt a little bit complicated and hard to grasp, right? So I'm doing it this way so you can grasp the concept really well. So the unary relationship means that there is only one entity in the relationship. It simply relates to itself. Other type of relationship is a binary relationship where you have two entities participating in one relationship. Then you have a ternary where you have three entities participating in one relationship. So in this example, you have works. You have the employee, works in a branch, and works on job. In the next section, we'll be taking a look at aggregates. So far, we have looked at our conceptual model. Now in this section, we're going to be choosing our data model. There are 4 different types of data model to choose from. You have the network, hierarchical, relational, and object-oriented. Now in this section, we're going to be using the relational model. By the end of this section, you'll understand how to convert an ERD to relational notation, understand relational keys. You'll also have a strong understanding of integrity rules and understand how to convert relationships. In this section, we're going to be explaining normalization, explain the terms partial dependency and transitive dependency, and how to normalize a database up to third normal form. So before we go any further in this section, it's very important that we understand what is the relational model. Now, the relational model is a foundational approach to managing and organizing data in a database. This was first introduced in the 1970s by Edgar F. Codd and remains the basis for modern database management systems. So it is in the relational model we will convert our conceptual model into a relational model. It is also important to note that it is more detailed than our conceptual model. This is the model that enforces integrity constraint to maintain data accuracy and consistency. So the relational model enforces integrity constraint to maintain data consistency and data accuracy. Constraints such as entity integrity, ensuring primary key uniqueness, and referential integrity, ensuring relationships between tables are maintained, are commonly used. This is where we introduce keys such as the primary keys, foreign keys, and unique keys. Now, relations in the database are represented by rows and columns. So from our conceptual model, entities typically become relations, right? A row in the database represents a record, and the columns represent attributes. Now, an attribute can appear in any order and the relation will still be the same relation. So it doesn't matter the order of the attributes, it will convey the same meaning. When you're designing your database, guys, normalization plays a very important part. Now, this is the process where you structure your relational database in a way that reduces redundancy and dependency among data. Now, its primary goal is to organize data and minimize duplication, avoid anomalies, and improve data integrity. So when I say anomalies, I'm particularly referring to update, delete, and insert anomalies. It also ensures that data within a table are related. So in a customary table, you cannot have product data unless, for example, it's a foreign key. So now we're going to be taking a brief look at functional dependencies. So here we have a simple relation called student. We have the student ID, first name, last name, and an email address. So for our functional dependency, we have student ID, where first name, last name, and email address is dependent on student ID. That means when you search the database by the student ID, you can use it to locate any of these values. So we say the student ID functionally determines the first name, last name, and email address, and email address, last name, and first name is functionally dependent on student ID. And the other fields or attributes are typically dependent on your candidate key or your primary key. So guys, an update anomaly is a problem that occurs in your database when it is not properly normalized, right? So this happens when updating data leads to inconsistencies because the update is done in some but not all the places where the data appears. So let's look at this example here. We have an inventory table, right? We have product ID, product name, warehouse name, and city. Now let's say we wanted to update the James Lane warehouse, right? And let's say we wanted to change it to James Avenue. We'd have to update it here, and then again we have to come and update it here. So how do we solve this? We break it out into different tables. So now we have a warehouse table and we have a product table. So if I update the James Lane warehouse name here, once I write my query and reference the warehouse ID, it will get the correct name. So I don't have to go through the entire database and make an update for wherever that James Lane appeared. Because you're going to be having multiple products, right? And if you're supposed to go through your database and make the changes everywhere, you can see where that can become a pain because a database table can have millions of records. You also have insert anomalies. Now here we have the same inventory table again. Now let's say we just wanted to add a product, right? So here the warehouse name is part of the primary key. So if we're supposed to add a new product called microwave with an ID of 104 and we just wanted to add the product, what will happen to the warehouse? We'll be forced to add a value for the warehouse, right? Because it is a part of the primary key. But we only wanted to insert a product. We didn't want to associate it with a warehouse. So the solution here would be to have your tables normalized. So you have your product table and your warehouse table. So if we go back to the previous slide, in this case where the warehouse ID is a foreign key, you could add a product, but you do not have to specify a warehouse ID because remember, your foreign key can be null. So let's go on to the next lectures. So your delete anomaly is the opposite of your insert anomaly. So if you wanted to delete data from a table, you'd end up deleting data that you may not want to delete. In this case, if we wish to delete only product 103, which is the water bottle, then what will happen to the warehouse? We'll be having to delete a warehouse that we do not want to. So guys, when we're normalizing our database, we can go up to fifth normal form. So you have the first, second, and third. Then you have one called BCNF, also known as Boy's Code normal form. Then you have the fourth normal form and the fifth normal form. In the next lecture, we're going to be taking a look at first normal form. In this lesson, we're going to be taking a look at how we can convert an ERD to relational notation. This is a continuation from the previous lecture, so feel free to switch back to the previous lecture and look at the ERD diagram. And this is very easy to do, guys, right? So if you look at my screen now, you'll notice that we write it out in the form of sets. So I have the customer entity and the phone entity. Now if you look carefully, the customer ID, which is the primary key, is underlined. And then we have the other list of attributes. Now the order doesn't matter. However, it's important that you underline your primary key with a full unbroken line. Now if you look at the phone entity, you'll see that we have the customer ID. In this case, it's a broken line which denotes the foreign key. So it is used to reference a customer in the customer entity. But now you should be seeing that there's something missing. Where's the primary key? How do you identify the primary key here? Well, we need to underline our phone ID so it's denoted as a primary key. Otherwise, your relational notation is not complete. So it's important to note that whenever you have like a foreign key, you should always note it. The foreign key customer ID references customer, and it should be under the respective notation. So that's it in a nutshell for relational notations. In this lesson, guys, we're going to be taking a look at first normal form. Now, at this point, I don't want to be worrying because it may sound a little bit technical, but it is not. I promise I will make it clear as we go through the steps. Now, to determine if a relation is in first normal form, there are a few characteristics that you need to understand to know if a table is in first normal form. Now, the first one is atomic values, right? Each cell in the table must hold a single value. So for simplicity, you cannot be storing, say, first name and email address in the same column. Every column should have a unique column name, and each column should contain values that are of the same data type. In the section on physical design, you will understand what are data types. So basically, you can't be storing an integer and a string in the same column. All columns in the table are dependent on the primary key, and there should be no columns with a S. For example, emails. So anywhere you see something like emails, that's a red flag. So here we have an example of an unnormalized student table. So if you look carefully at the course column, you'll notice that we're storing multiple values in the same column. So here, we should not be having any list or composite structure in a column. So how do we get this to first normal form? Let's look at the next slide. So to transform the previous table, what we did was to store each subject as a single value. So let's look back again at the unnormalized data. We were storing a list of data in a single column. So to move this unnormalized table to first normal form, what we did was to store each course as a single value in the student table. So let's look back at it again. And here we can see that we have English, Math, Spanish, and geography, biology, and social study. So each student course assignment is in a separate row. Here we have an example using an ERD. So this is just a sample customer entity where we have the customer ID attribute, first name, last name, and we have emails. If you remember, there should be no S and an attribute. So to transform this relational notation to first normal form, we need to create another entity for emails. So this is what we currently have, right? And now we need to break this out into two entities. So our solution is going to look like this, right? A customer ID, which functionally determines first name and last name. And for our second table, we're going to have email, which is the entity, and the customer ID, which functionally determines the email address. So why do we do this? A customer can have multiple email addresses, right? It can have a primary, secondary, and a tertiary. And if you're supposed to store this in one column, you would have to be separating them by commas. And that would be violating the rule of first normal form. So to correct it, we create another entity called email. So to summarize, guys, first normal form says that a domain of an attribute must include only atomic values. So you cannot have a range of values or a list of values. In the next lecture, we're going to be taking a look at how we can move to second normal form. In this section, we'll be taking a look at second normal form. First, the database table must be in first normal form. So that means our columns are not storing any list of values, or in other words, the columns are atomic. A table is in second normal form when there's no partial key dependencies. So each non-key attribute depends on the entire primary key. So functionally dependent means that by identifying an attribute or combination of attributes, other attributes can be determined from those. So it's important to note that if there's no composite key and the relation is in first normal form, then it is also automatically in second normal form. So let's look at an example. So here we have an example of the inventory table, where we have a composite key of product ID and supplier ID. Now remember, for the table to be in second normal form, all non-key attributes must be dependent on the entire primary key. So cost and supplier must be fully dependent on the entire primary key. But is that so? So if we know just the product ID, can we find out the cost? In this case, no, because we can have the same product from a different supplier with a different cost. So if we only know just the product, we can't determine the cost of the product. That means the cost is fully dependent on the product ID and the supplier ID. Now, if we know just the supplier, can we find out the cost? No, because we need to know which product it is as well. So because we cannot use just the supplier ID or the product ID to find the cost, that means the cost is fully functionally dependent on the product and the supplier ID. So the partial dependency again refers to a situation when an attribute in the table is fully functionally dependent on only part of the primary key rather than the entire primary key. Now let's take a look at the supplier address. Now if I know just the product ID, can I find out the supplier's address? In this case, the answer is no. Why is that so? Because there can be more than one suppliers for the same product. So we could have company A supplying water bottles and company B supplying water bottles. So if you're supposed to try and look up the supplier's address based on the water bottle, you would only find one address, but you should, so let's say you have two suppliers, you would miss an address because you have more than one addresses. Now if I know just the supplier ID, can I find out the supplier's address? Well, in this case, yes we can, because the address is not dependent on the product ID. Therefore, the supplier address is not fully functionally dependent upon the entire primary key. So how do we solve this? Well, the solution is to create a new table or entity. So let's take a look at the solution. So when we are converting a table to second normal form, we need to convert partial dependencies. And the first step in achieving this is that we create a new table for each primary key attribute that is the determining factor in the partial dependency. So to move this inventory table to a normalized form, we need to create a new table. Once we do this, we now have two tables, right? So we have the inventory table and we have a supplier table. So the supplier ID now becomes a primary key in its own table and it becomes a foreign key in the inventory table. So now we need to add the non-key attribute that were dependent on the primary key. So now we have the supplier address, which was the non-key attribute, which was dependent on the supplier ID, which was the primary key in this initial inventory table. So now we should only have two tables, right? We have the inventory and the supplier. So these entities are now in second normal form because there is no partial key dependency. And the supplier ID now becomes a foreign key in the inventory table. So let's go over that one more time. So to move a table to second normal form, we need to get rid of partial dependencies. So in this table, the offending attributes were supplier ID and supplier address, because we can determine the supplier address only by the supplier ID. All keys should be functionally dependent on the entire primary key. That means you should not be able to determine a non-key attribute using part of the primary key. To solve this, we create two entities. So what we did was to create a new table for the primary key and move the non-key attribute that was dependent on the primary key to that table. So now we are in second normal form. So to summarize, if there is no composite key and the relation is in first normal form, the entity is automatically in second normal form. To take a table to second normal form, we address partial dependencies within the table. So no non-key attribute should be partially dependent on part of a primary key within a table. In the next lecture, we'll be taking a look at third normal form. So guys, in this lesson, we're going to be taking a look at database relational keys. Now, in the realm of databases, keys plays a crucial role in organizing, identifying, and establishing relationships between different entities in the database. They ensure data integrity, enforce relationships, and allow for efficient retrieval and manipulation of data. So let's take a look at the first one, which you're no stranger to, right? So you'd have heard me talk about the primary key several times. So as you know, the primary key uniquely identifies each record in the table. So when you think of, say, a customer table, you can have many customers with the same first and last name. So how will you uniquely identify a customer? You can use a primary key. So this primary key could be an email address or an ID number. It also ensures data integrity and serves as a reference for relationships between other tables. So if a customer purchases a car, how will you know which car was purchased by which customer? So this is where the primary key becomes what is called a foreign key in the other table. So that is how it is used as a reference for relationships between tables. A primary key can be implemented as a single field or a combination of fields. You'll soon understand what I mean by this. So this is an example of what a primary key looks like when you create a database diagram. You will see the little key beside the primary key. So the primary key is what becomes a foreign key in another table. So as you can see again here, it establishes a relationship between two tables. So it references the primary key of another table. So like the foreign key, it maintains referential integrity, ensuring that data in the foreign key matches data in the primary key. So here we have an employee table where the business entity ID is the primary key. Now when we look at the employee department history, we'll see that it has a business entity ID, which is now the foreign key in this table, right? So the foreign key references this business entity ID. So that's how it maintains the relationship between the two tables. So this is how you can track the departments in which an employee moved in a company, right? So if they work in IT department, if they work in the sales department, if they work in the accounting department, then this table allows you to track it. So it will track their department ID, their shift ID, their start date, as well as an end date and modified date. You also have the composite key. So as the name suggests, it is one or more keys come together to make this key a primary key. So as the name suggests, it is one or more key that comes together to uniquely identify a record in the database. So to see how this works, we're going to be taking a look at an example using a car rental company, right? Where the car rental company want to track which customers borrowed which car. Now, customers may rent cars more than once, but not on the same day. So if you think about this now, you're going to be having two entities, a car entity and a customer entity. Now, if you think about it, we will need to track the date the car was borrowed, right? So let's say we are going to call this attribute date borrowed. A date borrowed cannot be an attribute of a car, and date borrowed cannot be an attribute of a person. So where do we put this date borrowed, right? So we'll be putting this date field on the relationship. So let's take a look. So here we have the customer entity with their customer ID, first name, last name, DOB. And here, if you look carefully, we have the attribute called date and the car rental. And then here we have our final entity, which is the car. So think about it again. If you purchase a car, it will not have a, say, a date rented on it, right? So we'll keep track of the date and the rental relationship. So now let's look at this in the relational model. So as you know, we'd write out our customer entity, and car rental entity here. So if you look at the car rental, the customer ID, the chassis number, and the date will now come together and make a composite key. But if you think about it, within the car rental, customer is a foreign key as well as chassis number. So we are missing something here, right? So this is where you need to add your underline to distinguish that it's a foreign key, which is now acting as a primary key. And it is the same thing with the chassis number because they all combine together to make a primary key. So here, all of this is a composite key. And here we would have like our comment that says foreign key customer ID references customer and foreign key chassis number references car. You also have super keys. So your super keys are typically referred to as your primary keys and like your unique key and your foreign key. So these are keys that uniquely identify a record table or ensure uniqueness within that table. And last but not least, you have the candidate key. Now, a candidate key is the minimal set of attributes that can uniquely identify a record. So typically among the candidate keys, one is selected as the primary key. So for example, a person can have an ID number, they can have a social security number, They can also have an email address, right? So all those three that I just mentioned are candidate keys. So from your candidate keys, you will select your primary key. In the next lecture, we're going to be taking a look at relational integrity rules. So in this lesson, guys, we're going to be talking about the types of integrity rules. So as the name suggests, right, integrity rules in the database help maintain the accuracy, consistency, and reliability of data. So there are three main types of integrity rules. The first one is that you have the entity integrity. This ensures that each row in the table is uniquely identified by a primary key, and that primary key column does not contain null or duplicate values. So in other words, if you have a customer with a social security number or TRN, whatever the tax ID is in your country, then when you set that tax identifier as a primary key, you cannot have a duplicate in the database. So it is implemented using the primary key, and your primary key must have a value. Now the second one is the referential integrity. Now the referential integrity states that if a foreign key exists in a relation, either the primary key value must match a primary key value of some tuple in its own relation, or the foreign key must be null. So in other words, you can't have a foreign key that exists and there's no primary key for it. But you can have a foreign key that is null. Now last but not least, you have the domain integrity. So this defines the acceptable range of values for a particular column, ensuring that data entered in the column meets the specific criteria. So this could be your data type, your format, or constraint. So an example of this could be in a database you can store gender, and you can have either MRF for your gender. Now to enforce this integrity, you will implement what is called a constraint. So when data is entered into the database, the value must be MRF, otherwise the insertion will fail. So by implementing these integrity rules, guys, this allows the database to maintain consistency and accuracy, preventing invalid or inconsistent data from being entered or stored in your database. Now, once we get into the practical section of this course, you'll see more of this in action. So you would have heard me mention null when I was speaking about entity integrity and referential integrity, and maybe it came to your mind what is null, right? So null refers to the absence or the lack of data in a field or variable. It doesn't signify zero or an empty string, but rather represents a missing, unknown, or undefined value. So again, guys, when we get to the practical section of this course, trust me, you'll find it fun and interesting of how these things actually work in the database, and you'll have an appreciation for it. In this lesson, we're going to be taking a look at third normal form. Again, guys, normalizing your data is transitory. So in order to get to third normal form, first we have to go to first normal form, second normal form, and then third normal form. So to comply with third normal form, a table should be in second normal form, and there is no non-key attribute that functionally determines another non-key attribute. So this is what we call transitive dependency. So let's take a look at this simple example. Here we have an entity called sample. It has attributes A, B, and C. So here we have A, which is a primary key, functionally determines B, and B, which is a non-primary key, functionally determines attribute C. And if you take a look here, B is not a candidate key. So this is how transitive dependencies come about. We have an attribute which is dependent on a non-key attribute. So the solution is to create another entity. So now we have two entities. We have the original sample entity, and then we have sample B entity. So the non-key attribute B, which C was dependent on, now becomes a primary key in its own entity, and is now a foreign key in the sample entity. So here we have another table with employee info. We have the employee ID, name, department, and department manager. So for this table, the employee ID is the primary key. And we have department, which is a non-candidate key, which is determining manager. So the solution is to create another entity for the department. So to achieve third normal form, right, we have to split it into two tables. So here we have the employee info, and then we have the second entity, which is department. So in the department entity, the department attribute becomes the primary key, and in the employee info, it then becomes the foreign key. So to achieve third normal form, what we need to do is create another table for the non-key attribute, which was used to determine the other attribute. So in this case, it was department. So we created a table called department and made the department attribute the primary key. And in the employee info table, it became the foreign key. So we no longer have a non-key attribute determining another attribute. Or in other words, we no longer have a non-key attribute dependent on a non-candidate attribute. In the next section, we'll be starting the physical design and implementation of our database. In this section, you'll be introduced to SQL, which is essential for designing and implementing a database. You'll understand the different types of SQL statements and understand what are data types. In the upcoming lecture, we'll be taking a look at SQL. So SQL stands for Structured Query Language, and it is a computer language that we use to interact with a relational database. So how is it really pronounced? You can call it SQL or SQL. I use them interchangeably, right? So SQL lets you write what is called queries to retrieve, insert, update, and delete record from a database. It also allows you to create and modify database structures such as table views, indexes, and constraints. It is a standard language that is supported by many database systems such as MySQL, Oracle, SQL Server, PostgreSQL, and SQLite. It is also a declarative language, which means that you specify what you want to do, not how you want to do it. The database system will figure out the best way to execute your query and return the results. It also supports some procedural elements such as variables, functions, and store procedures that allows you to write complex and dynamic queries. SQL is also the foundation for data analysis. It's a very powerful and flexible tool for working with data. SQL allows you to perform tasks such as filtering, sorting, aggregating, joining and transforming data, as well as creating reports, dashboards, and charts. SQL can also be integrated with other languages and tools such as Python, R, Excel, and Power BI to enhance your data analysis capabilities. In the next lecture, we're going to be taking a look at the different types of SQL statements. There are four main types of SQL statements. The first type we have is the data definition language, often referred to as DDL statements. These statements are used to create the structure of our database. These SQL statements are typically create, alter, and drop commands. The next set we have is data manipulation language, often referred to as DML. These commands manipulate data within the database. So this is typically your insert, update, delete, and select statements. And last but not least, you have the data control language, typically referred to as DCL commands. These are related to managing permissions across your database. So this is typically your grant and revoke statements. So these are the core of database design and implementation. Without these, you can't even create a database. So in the next lecture, we're going to be taking a look at data types. So the data type of a column defines what value the column can hold. So that is like an integer, character, money, date and time, binary, string, so on and so forth. So if you recall earlier, for your table to be in first normalization, you can store different data types in the same column. So from the physical design aspect, you can store integer and string within the same column. So what are some of the most common data types? So for this course, we'll be mainly using integer, decimal, varchar, char, and date. So we'll not necessarily be using the text, but it is a very common data type for storing large amounts of data. In the next section, we'll be moving on to setting up our environment to start get our hands on. In this section, we'll be setting up our environment. We'll be setting up one in the cloud and one on your local laptop. Now, I'll be setting up the environment in the cloud because if you want to follow along using databases like MySQL, Postgres, or Oracle, you can easily create an environment in the cloud to follow along using those platforms. However, throughout this course, we'll be using SQL Server. So what we're going to do is that we're going to be installing the management tools like SQL Server Management Tools, MySQL Workbench, and SQL Developer. These are the various tools that you'll use to manage your databases. So we'll be setting up these first and then we'll be setting up our environment because we'll be using the management tool to connect and interact with our database using SQL. So with that said, let's go over to the next lecture. So guys, the first application we're going to be downloading is SQL Server Management Studio. This Management Studio is used to manage SQL Server databases. So you can get it directly from Microsoft's website. I can Google SMS for short. That stands for SQL Server Management Studio. So select the first link. It will take you to the Microsoft's website. And then select this link to download Management Studio. Management Studio will also come with Azure Data Studio, which is a cross-platform software. So if you are taking this course from a Mac, you can follow along using Azure Data Studio. So as you can see here, for customers needing a cross-platform companion to SMS for managing SQL Server and Azure databases, use Azure Data Studio. So I'm just going to open the executable file, select install. So this will take a few moments to install. So the installation has been completed for SQL Server Management Studio and Azure Data Studio. Now one thing to keep in mind with Azure Data Studio, you can use it to manage other databases such as Postgres and Oracle. I'll get into that later on. In the next lecture, I'll be installing pgadmin. This is the dedicated application for Postgres databases. In this video, we are going to be downloading and installing pgadmin. So from your browser, you can search pgadmin and select the first link that comes up, right? So ensure that you're going to the website that says www.pgadmin.org, right? So here I'm going to select download. So I'm on a Windows, so I'm going to download the Windows version, right? I'm going to be downloading the latest version, which is version 7.4, right? So I'm going to download that. I'm just going to grab the executable here. This will take a few seconds to complete, literally less than 30 seconds. So once the download is complete, open the executable file. So if it's you alone who uses the machine, you can install for you only, which is what I'm going to do. So here I'm going to select next. I'm going to accept the agreement and then I'm going to select next. This is the location where it will be stored. Then select next to continue and then select install. Select finish. From your start menu, search for pgadmin. That is if you're on a Windows, right? So I'm going to select pgadmin version 7. So this will take about a minute to launch. We have successfully launched our pgadmin. In the next lecture, we'll be setting up SQL Developer. This is used to manage Oracle databases. In this lesson, we're going to be downloading SQL Developer for Oracle. This is ideal if you want a dedicated tool to manage your Oracle database. To download Oracle Developer, head over to oracle.com/database/SQL Developer. Once you're on the page, all you need to do is select Download SQL Developer. So for this course, I'll be downloading the Windows 64-bit with JDK 11 included. So hit download, accept the license agreement, and select download. It will prompt you to log in to the website. If you don't have an account, create one to proceed with the download. Once the download is completed, open and extract the file. So I'll be extracting this to my desktop. Once the extract is completed, open the application file. In order to create a connection to the database, select the plus icon. However, we do not have a database as yet, but further on in this section, you'll see where to get your connection details. If you are planning to use MySQL database for this course, you can use its dedicated product, MySQL Workbench. To download this product, go to mysql.com/products/workbench. On the home page, just select Download Now. Select your operating system. I'm working with a Windows, so I will keep the default. And I'll be downloading the MSI installer. So here I'm just going to select Download. If you do not have an account, sign up for a download. However, I do have one, so I'm just going to select Login. So I'm just going to sign in here. Complete the short survey. Select your job function. Select the number of employees, you can select one. And then complete this verification. And then submit form. Then here you can proceed with the download. Once the download is complete, open the executable file. So here I'm going to select next, complete, and select install. Once the installation is complete, select finish and launch My Workbench now. In order to create a connection to your database server, you would select the plus icon, specify a name for the connection, the host name or the server name, the port which you are connecting to. Typically, the default is 3306 and the username. And then you will specify a name for the default schema that you want to connect to, and then you will select OK. So that's pretty much how you'll connect to your MySQL database. In the next lecture, we'll be setting up our cloud environment. In this lesson, we'll be going over how you can create a free account with AWS. Now, AWS is a cloud platform where you can host your databases and other applications. They offer a free tier that you can use for practicing and development. So you'll go to aws.com/free. When you scroll down on the page, under the database section is a section that we're interested in, right? So we'll be using what is called RDS database, Amazon RDS. So RDS stands for Relational Database Service. So they are fully managed database services when compared to if you created a server and installed the application. So for the free tier here, we can utilize MySQL, PostgreSQL, MariaDB, or SQL Server. So to get started, you can select Create an AWS account and provide all the relevant information. You'll be asked to provide a credit card or debit card. However, you will not be charged unless you go over the threshold. And for this course, you won't, and they will typically send you an email if you reach that threshold. However, I do have an account, so what I'm going to do now is sign in to an existing AWS account. So here I'm just going to select sign in and then sign in again. Now on the home page there is a search box, so what you can do is search for RDS. Select RDS, select create database, scroll down. From here you can create any one of these databases that you want to use for this course. So here I'm going to select the easy create option. I'm going to go with Microsoft SQL Server. Scroll down, select the free tier and specify a name for your database identifier. I'm going to call this UdemyDB. Scroll down. This is the username that you'll use to log in to the database server or managed instance, right? You can set a password or auto-generate one. I'm going to go with the auto-generate a password option and then select create database. Here I'm just going to close this notification. I don't want any other one right now. This will take a minute or two to complete. Here at the top it says view credential. So I'm going to view this credential and save my admin password. Now this option requires that you have an internet connection all the time to complete this course. However, if you do not have internet connection all the time and you may download the videos offline, then in the next lecture, I will be showing you how you can set up your SQL Server instance offline. But for the rest of this course, I will be working with the RDS SQL Server. So the database has been created and is now available. However, we can't access this immediately. We need to allow public access. So select the database identifier, select modify, scroll down, expand additional configuration, and select publicly accessible. So this is for the purpose of this course only, right? Scroll down, select continue, select apply immediately, and then select modify database instance. So the database has been modified successfully. Now we need to connect to our database. So select the database identifier. So in order to connect, we're going to need our endpoint. And even though we allow public access, you will not be able to connect directly unless your IP is in the security group. So let's copy this endpoint for now. Select the VPC security group. It's right here. Select on the group ID, and here you're going to select edit inbound rules. Select add rule. From the drop down, search MS SQL. Select that option, and for source, select my IP, and then select save rule. Now launch Azure Data Studio. Select create a connection. For the server name, specify the endpoint name. For the authentication type, from the drop-down, select SQL login. Now if you did not change the default admin username, then your username will be admin. And your password is the auto-generated password or the password that you specified. The other option that we need is, so we're going to call this Udemy database design. So it's an optional parameter, but it allows you to identify your connections, right? So we are going to select connect here, enable trust server certificate, and now we are successfully connected to our database instance. So to get your version of SQL Server to work with for this course, you can get over to the Microsoft website. So what you need to do is select downloads. Do not select Try SQL Server 2022 because that will be the version that you need a license for. So you're going to scroll down to the section that says Developer or Express Edition. I recommend going with Developer for this course. So select Download. Once the download is completed, open the executable file. Here you have 3 installation types. You can go with basic, custom, or download the media, then execute. So for the basic installation, it's going to do an installation without you doing any customization, but that is not ideal for a production environment. I want you to get the full experience just like how you'd set it up in an organization. So select custom. Here it is showing you the media location where the files will be downloaded. So select install. So wait a few minutes for the download to complete. So once the download is completed, it will automatically pops up this installation center. So from here, select installation, select new standalone installation, and then we're going with the developer edition. Select next to proceed. Accept the license terms and privacy statement, then select next. Select next to continue. Here you have a firewall warning. You can select next to continue. So for this course, we don't need the Azure extension, so uncheck. Then select next. On this page, select the feature that you want to install. We only need the database engine services for now. Then select next. On this page, you need to select your instance ID. So the default is MS SQL Server. You can install as many as 50 instances on a single server, so that's why it is possible to have named instances. So for instance, if I check named instance, I could specify a name that I want for my instance ID. However, I am going to go with the default. Then select next to continue. So here you have 3 services that will be installed with your installation. So we have the SQL Server agent, which is startup type is manual, the database engine is automatic, and the SQL Server browser is disabled. So we want to keep the default as is, so select next to continue. When you're installing your server, you have to select an authentication mode and specify users that will be able to connect to your database. If you don't specify, you won't be able to proceed to the next step. So you can enable mixed mode authentication. Users can connect with a username and password as well as using Active Directory. So specify a password for your SA. This is your system administrator account and it has all the elevated permission to administer your database. Now within your organization you could do a add and add another user from within your Active Directory location, right? However, I'm just a current user, so I'm going to select add current user. If I don't add current user here, I won't be able to access the SQL server when it's up and running. The other important tab on this page is the data directories. This is where you specify where you want your database files to be stored, as well as your log files and your backup directory. So I'm going to change this from the C drive. You don't want to have any database files on your C drive. As for my database, I am going to change the transaction log and specify the one that says log. And I am also going to change the backup directory. So ideally within your organizations, you'll have multiple drives where you can specify these log files. The other file location you want to change is your temp files. You don't want to keep them under your C drive. However, because this is just a laptop and a test environment, I am going to keep it as the default for now within the C drive. And the maximum degree of parallelism page, you can keep the maximum as the default. And for the memory, here's where you can specify the amount of memory you want SQL Server to use on your machine. Because this is just a test environment, I am going to limit it to about 4 gigs. But ideally, you want to give your server as much memory as possible for it to run efficiently. File stream is fine, you don't need to change anything on the file stream tab. So I need to accept the recommendation and then select next to continue. So this is just a brief overview of your configurations. Select install to proceed with installation. This may take a few minutes to complete. The installation has been completed and now I need to reboot my computer for the process to complete successfully. In the next lecture, I will be sharing with you how you can connect to your local SQL server using Azure Data Studio. We'll also be taking a detailed look at Azure Data Studio. So in this lesson guys, we're going to be connecting to our local SQL server that we installed in the previous lecture. So from your start menu, search for Azure Data Studio. Now it's important to note that it doesn't matter which database engine you plan to use for this course, you can use Azure Data Studio to perform your queries, and I'll show you how to do that shortly. So to create a new connection to your local database, you can select create connection here. You could also select new here and you could also select this plus icon here. So I'm just going to go with this one for now because in the first video we did just select create new from the home page here. So we're going to keep the connection type as MS SQL Server. The reason why we only have one option though is because I have not installed any other extension. So for the server name, it's the name of your computer. If you don't know the name of your computer, you can go to my computer. So the easiest way to do this is go to your start, select a folder, open an existing folder, scroll down until you see this PC, right click and then select properties. So what you want to grab is your device name. So let's copy this and paste it here in the server option. Then for the authentication type, you can keep it as Windows. And then for the name connection, you can call this local SQL server. So in order to connect, you just hit connect. So now just enable trust server certificate. So we are now successfully connected to our local SQL server. And here above it, I have the one for my AWS. And when I expand, I can see my databases. So guys, most of the shortcuts that you are familiar with, for example in Windows, like Ctrl S are applicable here. If you do not like this default theme, you have the ability to change your theme. So what you can do is select settings, color theme, and you can navigate between the themes and choose one that you like. You have the ability to change things like your font by selecting the settings icon and then select settings. So for this course, I'll be increasing the font to 14. You can change your font family as well. However, I'm going to keep the default. Now if you plan to use Azure Data Studio to connect to your Oracle database, your MySQL database, or even Postgres, what you need to do is install the extension. So you'll go over to this little icon here that says extension, or you can do Ctrl+Shift+X and it will take you to this section. So here I can install a plugin for MySQL, I can install a plugin for Postgres, and if I search for Oracle, I should see the option for Oracle as well. So for demonstration purposes, I'm going to install the Oracle extension, right? So it's installing now. To go back and create a connection, select the server icon, select plus again. Now for the connection type, when I select the drop down, I'm seeing Oracle. Now if you're connecting to an Oracle server, for the data source, it's going to be the name of the server. For example, my server name is MRJM. Then you're going to put a colon, the name of the database, for example, it's Udemy. And then you're going to specify a comma and then the port. The port is typically 1521. And this will allow you to connect to your Oracle database using Azure Data Studio. Now, in the next lecture, we're going to be getting into the actually cooler stuff. So we're going to be creating our database and start implementing our ERD diagram. Guys, the moment you have been waiting for all this course, how do we get practical and move from all the theory to the physical stuff? So in this lecture, we'll be implementing this ERD diagram. Now, I'll be keeping it very simple in terms of the number of entities and attributes, because once you understand the basic concept, you can always apply it to a larger ERD. So let's say I had used a larger ERD with more entities and attributes. What will be happening is that we'll be basically doing the same stuff repeatedly, right? So it doesn't make any sense really to implement a larger ERD. So once you grasp the concept here, using this small ERD, you can implement larger ERD diagrams, because it will be basically create and insert statements going forward. So let's head over to Azure Data Studio to get started. So what I want to do is open a new connection to your database server. So how do you do this? Select File and select New Query. So this opens a new session to your database server, and the default database it's connected to is the master database. To see the list of databases on the server, you can expand databases, and under the main databases, you'll see that we have one RDS admin. Now this is a database provided by Amazon Web Services, and we cannot make any changes to this database. When you expand system databases, you'll see a bunch of system databases that comes with the server, right? So we are not interested in any of these databases, and we have to create our own. So how do we do this? We can do this by using a create statement. So we're going to be creating a database called car rental, and this is very easy to do, guys. So it's create database. As you can see, we have auto suggestion here and the name of the database. So I'm going to call this car rental. So when I execute the statement by clicking the run, it creates the database. So when we go over to the database section, right click and refresh, we now see our car rental database. So currently, if we go ahead and create a table, here in this session, it will be created in the master database. So we need to switch our database. To do this, we can use the drop down by selecting the drop down and selecting the car rental, right? Or we could use the use statement. So if you said use and specify the name of the database, car rental. By the way, this is not case sensitive, guys. Car rental, and execute this statement, it will switch to the car rental. So let's demonstrate that. So I'm going to switch it to master. I'm going to highlight and execute. And you can see that it switched to the car rental database. So here you can see that I basically have multiple statements on the same sheet. To execute a single statement, I highlight the statement and hit execute. If I add a bunch of statements that I want to execute all at once, I would hit run. Now I expect this to fail because the car-rental database already exists. So here you can see that it says, hey, car-rental database exists. Choose a different name for your database. So like I mentioned before, you can use shortcuts like in, say, Microsoft Word. So if you're supposed to do Control S, it brings up the option to save the document. So you'll then browse for a directory where you want to save your script. So I'll be saving this as lecture 40, create statement. Now we need to start creating our entities. So let's look at the syntax for creating a table. In this lesson, guys, we're going to be taking a look at the create statement. Now, the create statement can be used to create any objects in the database, but for this section, we're going to be creating tables only. So first, we have the create command. Then we specify the object that we want to create. So here we said create database. Now we want to create a table. So we are saying create table. You will then specify the name of the table and then specify the fields, the data type, whether you want your columns to be not null or null. You can also set the primary key when you're creating your table, as well as you can set a default value when you're creating your table. Now please keep in mind that these are not required, right? But that's just the general syntax. But a rule of thumb, whenever you're creating a table, please create your tables with primary keys. So I also want you to pay close attention to the brackets. We typically enclose the fields in brackets. So you have the create table, the name of the table, open bracket, the fields, and then close bracket. Also keep in mind that after each column, you have a comma except for the last one here. So now let's look at an example table, right, with a create statement. So this is a create statement for an orders table, and in this create table statement we have an order ID which is an integer and we want it to be not null. We have an order number which is an integer and we want it to be not null as well. We also have a primary key which is order ID, so you can do your primary key just like this. Or you could have it in one statement. So you could do it like this, where you define the column type first, and then later on add it as a primary key. So let's go back to the first example. Here, everything was defined in one line. So both option works. And we also have a person ID. Now, when you look after that, we do not have another field, but we have a constraint. So we're saying constraint foreign key or the person, right? This is just allowing us to name the constraint, which is a foreign key, and it states the key, which is the foreign key. So it says this person here is the foreign key, right? So it is in brackets. And when you look in the second line, so let's put it in one line for simplicity. It says references person ID. So this would be another table called person, which has a primary key called person ID. So let's read over this constraint again. So it says constraint, the name of the constraint, foreign key. It specifies the foreign key and it tells which table it references. So this is how you create a connection between tables by using the foreign key constraint. Now what is a constraint really? They basically specify the rules for data in a table. So if you look at not null, this is also a constraint, right? And remember, a primary key cannot be null, and a foreign key can be null. So if you look at the person ID, we are not specifying any constraint like not null here. And if you look at the order number, it is saying not null. So you can't make an order without an order number. An order has to be associated with an order number. And remember, in one of our earlier examples, we had said that you could have an anonymous order. So there wouldn't be a customer or person who exists per se in the customer table to make that order. So that is why person ID can be null. Now, typically, when you are creating tables with relationships, you want to create the one that is the parent table. and the one with the foreign key last. So let's say we're supposed to execute this statement to create a table. So here we get an error: foreign key, FK person order, references, and invalid table person. So it's trying to reference a person table that doesn't exist, right? So the database is smart like that. And these are the things that enforce referential integrity. Guys, and at any point you need assistance in this course, feel free to message me, right? So now let's start creating our tables. So the first one we're going to create is the car table. So first we have the create command, then you have table, which is a type of object that you want to create, and then you have the table name, or in other words, object name. Here we have chassis number with a data type of varchar. Now the reason why we are saying 17 is that the typical length of a chassis number is 17. And here we're setting it as the primary key. We also have the color. The typical length of a car color, let's say blue or red, is less than 10 characters, right? But you may never know. And we are saying it's not null. That means when we are inserting data in this table, the user must specify a color for the car. We also have model, and we are saying the same thing. We are saying we can accept the length of 10 characters. We don't want it to be null, so we have to specify not null. And we are doing the same thing for make as well. So to execute this statement, we can highlight and select execute. So to create the car table statement, highlight and select run. The table has been created successfully. Now let's create the customer table. So remember, the primary key in the customer table is the customer ID and it's of type integer. Now you may be wondering, why do I not specify not null for the primary key? Because once you specify a primary key, you don't have to explicitly specify not null. We can also specify not null explicitly, right? So if I execute this, it will still create the customer table. So the table was created. Another attribute to note is the date type. Here we are not saying not null or null. So by default, it will be accepting null values. So when we are inserting records or data in the customer table, we do not have to specify a date of birth. However, we have to specify a customer ID, a first name, and a last name, because all these three attributes do not accept null. You have to specify a value. Let's take a look back at our ER diagram again. I've made a slight adjustment to the ERD. I've removed the customer ID, which was here, and here I denoted that the date is a primary key, because the primary key from customer ID and the primary key from the car entity, which is the chassis number, are combined together with the date and the car rental relationship to make a composite primary key. So for the implementation, I will be calling this relationship rents. Now let's also take a brief look again at our relational notation for the composite key. So for the composite key car rental, it took the customer ID, the chassis number, and the date field to make the primary key for the car rental. So the customer ID is a foreign key and the chassis number is a foreign key. So now let's take a look at how we actually implement this in the database. So let's create our rents table. So first we need to define our attributes. So I'm going to add some space here to make this a little bit more readable for you. So first we need to define our attributes that will make the primary key. So we have the customer ID, the chassis number, and date rented. Now in this case, when we are creating a composite primary key, we cannot explicitly say primary key for each attribute, right? We have to create the attributes first, and then we say primary key, and then specify the attributes that we want to be a part of the primary key. So that's what we are doing in this line. Now remember that customer ID and chassis numbers are both foreign key. So we now need to add these as constraints to the table. So the first one is the customer ID constraint. Now the order doesn't matter, right? Whether you want to do chassis number first or customer, the order doesn't matter. However, we need to define the attributes first. So we're saying foreign key customer ID, which is this ID here, references customer, which is this ID here. And that's exactly what we're saying. And it's basically the same thing for the chassis number. We're saying constraint foreign key chassis number. So this is just the name for the foreign key. And we're saying this chassis number here is a foreign key. And what does it reference? It references the chassis number in the car table. So first you identify your foreign key, and then secondly you identify the table and the key which it references. Now another important thing to note again, to maintain referential integrity, you have to keep the same data type. If it is not the same for the foreign keys, it will fail when you are creating the table. So let's look at the chassis number, right? The chassis number, we defined it as 16. So now let's try creating this table with 15 and see what happens. So let's execute. Here it says car number chassis number is not the same length or scale as the referencing column rents chassis number. So this time we're going to put the correct length, and then we're going to change the data type to char. So let's execute again. And you can see it complains again. Chassis number is not the same data type as the referencing column rents chassis number in the foreign key and the name of the foreign key, right? So it has to be the exact same as the primary key. So now let's execute this again. Now let's hit run, and our table has been successfully created. Now over to your left under your database, if you're not seeing the tables, let's minimize this. If you're not seeing your database, again, let's minimize everything. It's under the databases folder. So first you want to refresh, right? Expand databases, and then you'll see your car rental database. Now to view these tables, we can then further expand the car rental database. What type of objects did we create? Tables. So we can expand the tables folder. And here we can see the 3 tables that we created. When you expand any of them, you'll see another set of folders. So what we're interested in is the columns and the keys. So when you expand columns, let's bring this across a little bit. You'll see the columns that we created. When we were creating the chassis number, we did not explicitly state not null for the primary key. So here you're seeing it is saying not null for the primary key. However, we did explicitly state it for the customer. So if we expand customer, you will see it saying not null as well. So once you're defining the primary key, you do not need to specify not null. When you expand the keys folder, you will see the key that was created. So it automatically generated a name for the primary key. Now let's look at the rented table, right? So let's expand keys. And here you can see that under keys, it has the 2 foreign keys, and it also has the primary key. In the next lecture, we'll be looking at the drop statement. In this lesson, we're going to be taking a look at the drop statement. Now, the drop statement in SQL allows you to drop objects within your database. And not only just objects, you can drop your entire database. So it follows the syntax drop, the type of the object, and the object name. So what I'm going to do here is that I'm going to create a sample table called employee. So I'm just going to execute this in the car rental database. Let's pull this down. Now when we refresh the car rental database, refresh, expand, and expand tables, you'll be seeing the employees table. Now to drop this object from our database, we use the drop command. So let's drop the type of object that we want to drop, which is a table, and then the object name, which is employees. And then we just select execute. Now let's say we want to drop the customer table. To do this, instead of writing the script manually, you could right click customer and select script as drop. And here it generates the drop statement for you with a little extra information. Don't worry about this too much now. Now in my part 2 course for this, which is the Ultimate T-SQL and MS SQL Server Bootcamp, you can learn more about if statements and so on. So this course, guys, is just ideal for beginners. So I'm not going to go into the deeper stuff just yet, right? So what this statement is doing, it's checking if the table exists first, and then it's going to drop it. But don't worry about that for now, right? So if we're supposed to execute this anyways, it will fail. Why is that so? We could not drop the object customer because it is referenced by a foreign key constraint. Now, which table has that constraint? If you remember, in the rents table, we have a composite primary key. So let's expand keys, and you can see the customer ID. So in order for us to drop the customer table, first we have to drop the rents table. Now this is enforcing data integrity. So you can't have a database with orders but there are no customers. But you can have a database with customers and there are no orders. So you see where this all makes sense now, guys? And if you look carefully at these keys, they are denoted by different icons. So again, if you wanted to drop the customer table or the card table, first you have to drop any table with a foreign key or any table with a dependency. In the next lecture, we'll be taking a look at the alter statement. In this lesson, we're going to be taking a look at the alter table statement. The alter table statement is used to modify an existing table structure, such as adding, modifying, or dropping columns, constraints, and indexes. So we'll be going over some common use cases of the alter table statement. Now let's say you went ahead and created your customer table and you populated your table with a bunch of data, but now you have a new request to add a column called email. Now you can't recreate your table, so you have no other option but to alter your table. So you can achieve this using the alter table command. So this is the syntax for it. Alter table, the name of the table, add the name of the column and the data type. So if we're supposed to add the email column to the customer table, we will do it in a similar manner. So we're going to say alter table, the name of the table that we want to alter, which is customer, add the name of the column we want to add, which is email, and the data type. So the data type is going to be varchar. So for the length, I'm just keeping it at 54 now. Now the semicolon is optional, but depending on your preference, you can choose to use it or not. So let's execute this statement. And you want to ensure that you are connected to the right database, which is the car rental database, right? So let's execute. So the query executed successfully. Now let's refresh the customer table. So here's a refresh icon. Let's refresh, expand columns. And now we can see that we have an email address with a data type of varchar 50 and it accepts null. Also, if you have a column in your database and you want to get rid of it, let's say you want to drop the email address we just added, you can use the same alter table statement, but this time instead of adding column, you are going to drop. So let's copy and paste this statement here. So we're going to change the add to drop. But before we can execute, we need to specify column, right? And in this case, we do not need the data type. So let's execute the alter statement. So the command has been executed successfully. Now let's refresh the columns. So now you can see that the email address no longer exists because we dropped it, right? So the syntax is alter table, the name of the table, drop, then you specify a column, right? And then the column name. When you're dropping the column, you do not need to specify the data type. Now let's say when you create the first name and the last name, right? The width of the column, that is varchar 50, is too small and you need to increase it. What you can do is use the alter table statement again to change the data type. So let's look at the syntax. Say it's alter table, the name of the table, alter column, and the new data type. So it's going to be the same data type, but this time we're changing the width. So let's copy and paste. We need the customer table. The column we need is first name, and we're going to increase it to 100. So it's varchar 100. And we're going to do the same for the last name. So let's copy and let's paste. So let's change the first name to the last name. So we can execute the two of them simultaneously by highlighting the both of them and then selecting run. Now let's refresh the columns over here and you can see that it is now 100. There are times when you may implement your database and you have, say, a standalone table, just for example, address, right? So hypothetically, you are just storing address in the table. But now, because a customer can have an address, you need to now add a column in the address table as the foreign key for the customer ID. So to achieve this, you'll need to alter your table and add a constraint, right? So the syntax is like this here: alter table, add constraint, the name of the constraint, the foreign key column, references, and the table and the other column that it references, right? So to simulate this, I'm going to be creating a sample address table. So let's say I had this address table within my database, right? So let's create a table. But now a customer can have a address. To implement this relationship, the customer ID needs to become a foreign key in the address table. So if you notice, I created it without the customer ID. So we are going to be altering the address table and adding the customer ID. So let's go back to our alter table statements. So we want the one that will allow us to add a column to a table. So let's grab this one. So we need to change the table name from customer to address. And here we need to specify the name of the column that we want to add. So it's customer ID. And the data type is an integer, right? So let's specify int. Now let's execute. And we have successfully added the customer ID to the address table. Now we need to convert this customer into a foreign key. So we are going to grab the syntax for the constraint. So let's copy this. So the table name that we want to alter is address. So my bad, the foreign key name is right there and not here, right? So let me remove this. So the name of the constraint is FK customer ID. The name of the column is customer ID. And the table that it references is the customer table. So let's change this to customer. And the column that it references in the customer table is customer ID. Now let's execute this. Now I got an error. There's already an object name customer ID in the database. So basically I have to change the name of my constraint. So I'm just going to change this to FK address. So it's foreign key customer ID. So that's a new name. So that's unique. So let's execute. Now let's hit run and our table was successfully altered. Now let's refresh our tables, expand address, expand keys, and you can see that we have the customer ID, which is now a foreign key, which we added using the alter table statement. Now to drop a constraint, you use the alter table statement and then you specify a drop constraint and the name of the constraint. Now that should give you an idea as to why the name should be unique. Because if it doesn't allow unique names, when I say alter table, drop constraint and specify a constraint name, which one would it drop? Maybe it would go ahead and drop all of them if it had allow us to add names that are not unique. So now we're going to drop the customer ID constraint. So let's copy and paste. We're going to change the name of the table to address and the name of the constraint name is FKC customer ID. So let's execute this and the constraint has been dropped. So let's refresh keys here. We are no longer seeing the constraint name. However guys, we want to keep this constraint, so let's re-execute this alter table statement. Now before I go on to the next lecture, here are two things that I want you to note. You notice the address is highlighted. This is because address is a keyword. To avoid this, you can use brackets. So if you use bracket like this around those types of keyword, it will prevent it from being highlighted. So when you're creating database objects, you want to avoid naming your objects with keywords. Another thing I want you to note is the use of comments. To comment out a single line, you use these double hyphens, right? To comment out multiple lines, you use /, asterisk, and then you put asterisk and then /. So that's how you add comments in SQL. So this is the general syntax for other database systems, but they may vary a little bit, right? But this is the general concept across all relational database systems. In the next section, we'll be taking a look at data manipulation language. In this lesson, we'll be looking at the insert statement. There are several ways to use the insert statement. In this lesson, we'll be taking a look at 3 of them. So here I have on the screen is just the basic syntax for doing an insert statement. You have the insert into, then you specify the table name that you want to insert into, then you have the keyword values, and then in brackets, you'll specify the list of values that you want to insert. When you're inserting into a table, you can either do a full insert or a partial insert. Now a full insert meaning that you are inserting data for all the available columns that are in the table. So our table is currently empty, and to insert data in the table, we need to use the insert statement. So for this example, I'm inserting a record for Marco Jackson in the customer table, right? So the customer ID is 2, the first name is Marco, the last name is Jackson, and the date of birth is the 16th of the 10th, 2023, right? So this is a full insert for one record. Now I want you to pay keen attention to this. For the integer value, right, we do not have it in quotations. However, for the string data types, right, that is the first name, last name, and date, we do have them in quotations, right? So when we execute this, it should insert one record in the customer table. Now here I want to make a very important demonstration. Remember, the primary key does not allow duplicate values. So if I was supposed to execute again and check the database, we will not be seeing an additional record for Marco Jackson. So to view the data in the table, you can right click the customer table and select this option that says select top 1000 records. So if you look carefully, there's only one record in the table. Now to insert multiple records in a single statement, you would have your first set of records that you want to insert separated by a comma, then you provide the second set of data, then you specify a comma, and then you provide the last set of data, and then you can put a semicolon or you don't have to put a semicolon. It is not required, right? So to execute this, we just select highlight and select run. So this is how you insert multiple records in one statement. So if you're supposed to spread it out, it looks like this, right? That is what it would look like if you spread it out. Now let's take a look at the partial insert. Now the partial insert is where you do not want to insert all the records for a column. Whenever you're doing a partial insert, you have to specify the column names that you are inserting data for. So in this case, I'm doing a partial insert for customer. So I'm inserting the customer ID, first name, and last name. So I have to specify these values. And here I just specify the data for those columns. So when I hit execute, data will be inserted. So if I'm supposed to check my table again, you can do right click, select up 1000. However, I have it in another tab here. So I'm just going to select this tab and re-execute the statement. So here you can see that for Shane Maxim, there's no date of birth specified, but there's null. So null means that there's pretty much no data present. It is empty, there's nothing in it. And this is possible because I did not specify not null when I was creating the table, right? So let's go back on the main sheet. I'm going to attempt to do a partial insert into cars, where I have some columns where I specify not null. And let's see what will happen, right? So it's insert into the object name, car, right? So to double check the column, you can always expand the folder, expand columns. So I'm going to try and add just the chassis number only, specify values, and the number for the chassis number. So it's varchar and it goes up to 17, right? So that should be fine. Now let's execute this and see what happens. Cannot insert in the value not null column. So basically it's trying to insert null into the column, but it is not accepted. Why? Because the column does not allow nulls. So the insert failed. Again guys, these are some of the ways that you enforce data integrity and the quality of your data within the database, because a car cannot exist without a color in reality, right? It must have a color. So now let's look at the other insert statement. So you can also insert from a table into another table that already exists. To do this, you use insert into, the name of the table that you want to insert into. For partial inserts, you can specify the columns. You have your select statement, the columns that you want to insert, and the table that you want to do the insert from. So essentially you're saying select the data from customer table and put it into person table. For this to work, the object has to exist, right? So what we're going to do to create a person table for this demonstration is right click customer and select script as create. So what we're going to do here is change the name of the table from customer to person. So that is the only change we are making. Now select execute. So we have now successfully created a person table. So let's head over back to the insert statements. So let's execute this insert statement. Select run. You can see 6 rows was affected in the message section. So refresh table. So you right click on tables and select refresh. You can see we have the table which was created. So right click on the table and select the option that says select top 1000. So this is all the data which is currently in the customer table. So let's go back to the insert statements again. So you can do a partial insert and you can do a full insert using the insert into and select statement, right? So if we're supposed to remove this, we will be able to execute this, right? So select and run. So this was what I expected. Violation of primary key constraint. Cannot insert duplicate key in the person table. So let's go back to the create statement. What I'm going to do now is create a new table called person2 just for demonstration purposes and execute. Now let's go back to insert statement and here I'm going to insert into person2. Now let's execute and select run. So 6 rows was affected. Now let's refresh our tables. Select refresh and here we have the person2 table. So right click, select top 1000 and here you can see all the data present. So with this method, the table has to exist first. Now we have another option called select into where the table doesn't have to exist. So like the previous two examples, you can do a partial insert and you can do a full insert. So the syntax goes like this. Select, here you would have the table columns. Here you have the new table that you want to create from the select statement, right? And then this is your source table. So you typically do this when you want to back up tables, right? So I could say customer, today is the 23rd of December 2023. So when I execute this, it will create this table called customer 23/12/2023. So when I hit refresh, I will be seeing the table here. So if you do a select, so you right click, select out top 1000 rows, you can see all the data is present which is in the customer table. You can do a partial insert as well, right? So let me get rid of this. So here you'd specify the column that you want to insert. Here you specify the name of the table again, and then in the from section you specify your source table. So here I'm just gonna call this customer new. Now execute this and let's run. Here we have 6 rows affected. Now let's refresh the table section. Right click, select top 1000, and here we can see that only the customer ID is stored in this table. So far, we have looked at how we can create a database, create a table, alter our table, drop a table, and insert data into our table. And briefly, you would have seen the select statement, but in this lecture, we're going to be taking a deeper look at the select statement. So this is the general syntax for the select statement. So when we're selecting, we can select distinct columns or we can select all columns, right? So you can list out all the columns that you want to select, and then you have the from clause, right? Then you have your where expression. Your where is used for filtering out your data. Then you can also group your data by using the group by clause. You can also do additional filter By using the having expression, right, you can order your data by a specific column in ascending or descending order. So the first example we're going to be looking at is selecting all the fields from a table. So to do this, you use your select clause. You specify an asterisk for all the tables from and the name of the table that you want to select. So you'd have seen this in the previous lecture. So let's highlight and hit run, and it returns all the data in the customer table. Now you're seeing more data because I had went ahead and inserted some additional records in the table, right? You'll have this insert statement attached to this lecture. So this will display all the data in the customer table. So if we do a select all from the car table, we'll see a list of cars, if any, in the car table, right? So let's specify the from. Now let's execute. And you can see that we do not have any data in the car table. Now typically you use your select asterisk or select all whenever you want to discover the fields that are in a table. However, it's bad practice to do this when you're writing reports. You only select the fields that you want to return in your queries. So here in the select statement, I am only displaying the first and last name from the customer table. So when I execute, you will not be seeing the other columns. This method can also be used to create views. Now views is another object. It's like a virtual table which sits on top of a table. So you can use it as a security mechanism because you may not want a person to have access to all the data within your table. So you create a view just to show the first and last name for that table. Again, in my more advanced course, you can learn more about these concepts, right? I could even do just the last name. So if I do a copy and paste, Control V, I just want to show the last name, right? So I just specify the last name only, highlight, and hit run. Then it will just return the last name for the customer table. Now we have the ability to just display certain records within the table. To achieve this, we will use a where clause in our select statement, right? So if we wanted to see the customer's first name and last name, whose last name is equal to Jackson, then we can use a where clause to achieve this. So let's copy and paste the statement. So the statement will remain the same, right? Now we introduce the where clause. So this is used to filter out our data. So here you need to specify your column, right? So we're filtering on last name. And what is our criteria? Our criteria is Jackson. So if you look at the list of last name here, we have 1, 2, 3, about 4 Jackson in our database. So let's enter the last name here, highlight and execute, hit run. And you can see that we have 4 customers with the last name Jackson. You can also use operators like the greater than operator. So let me copy and paste this again. So if we wanted to see all the customers, the ID number greater than 5, replace the customer name with the customer ID. And for the criteria, it's going to be greater, and for the value, it's going to be 5, right? So when we execute this, we'll see only those customers with last name greater than 5. So let's include the customer ID in the result as well. So select, specify the customer name, comma, and let's re-execute. Let's run this. And you can see that all the customers with the customer ID greater than 5 is displayed. Now as you can see that we can have multiple customers with the same name. So how do we distinguish them? It is a customer ID which uniquely identifies them. So if we only wanted the result for a specific customer, then the best filter criteria is on the customer ID, right? And in this case, we'll change the operator from greater than to equal, and then you specify the customer ID. So I want to find the customer first and last name where the ID is equal to 11. Which customer is that? Let's execute. And here we have the customer is Mary Steele. We can also utilize the AND operators in our query, right? So here I executed a select statement on the customer again, right? Now I want to display the list of customers where their last name is equal to Jackson and they have a customer ID greater than 7, right? So we're not expecting to see Marco and Stacy in the result set. So to achieve this, we will use the AND clause. So we're going to display the customers with last name Jackson and ID greater than 5, right? So I want you to think about the solution in your head, what your where clause is going to look like. So if you're thinking your customer ID equal 5 and last name is equal to Jackson, then you're correct. So when you execute this statement, you should only be seeing customers that match this criteria. So either equal here, so no customer match that criteria. But what we want is the customer ID greater than 5, not equal to 5. So these things do happen sometimes, guys. So let's execute again. You can see that we have two customers, Stacy and Marcus. So Stacy's customer number is 9 and Marcus's customer number is 12. We also have the OR operator, right? So in the AND, both criteria has to be true for the data set to be returned. Now in the OR operator, any one of the operators can be true for the data to be returned, right? So if we were supposed to say display list of customers with last name Jackson or ID greater than 5, then we'll be getting a different result set, right? So that means we'll be seeing the two other first Jacksons, right? And any other customer with their ID number greater than 5. So let's copy and paste this and make the modification to the where clause. So this time we're changing from AND to the OR operator. So let's execute the statement. So if you look at the dataset carefully, right, you'll notice that the 5 is missing from the result set. And you can see that we have all the Jacksons in the result set. So let's change the customer ID 10 so you can see the difference, right? So the result set will be smaller. Let's execute this. So these are the customers with ID numbers greater than 10. And the other criteria is where the last name is equal to Jackson. So these are the other customers with the ID number which is less than 10, but the last name is Jackson. So both criteria is true here. So let's say we had Mark as the last name. So even though we do not have a Mark in the database for a last name, we will still get some results, right? So in the OR operator, once one of the condition evaluated true, then you will get some results. Another popular operator is the IN operator, right? So it's pretty much the equivalent of a OR statement to an extent, right? Let's say we want to display a list of customers that have a last name of Dixon or Jackson. We can use the OR as well as we can use its equivalent operator, which is the IN operator. So to achieve this, we'll say select from customer. So first let's write select. I'm going to do select asterisk for now. From customer, we need a column that we're filtering on, and we're going to use the IN operator, right? And we're going to say IN. And for strings, they're going to be in quotation. And to separate the list of values, you specify a comma and then quotation, right? So it's going to be Jackson or Dixon. So let's execute this. And these are the customers who have a last name of Jackson or Dixon. So if we rewrite the same statement using the OR, we will get the same result. Now I want you to pay attention to something here. So if you're supposed to say last name equal Jackson or Jackson, this will not work. You have to use a field name each time. So you have to copy that. You have to compare the attribute or field name each time. So let's execute this and you'll see that we got the same result. So we can execute them together and you'll see the result set here. So guys, you also have the ability to sort your data using the order by clause, right? So you can sort data in ascending or descending order on any attribute within your table. So this is really easy to do, right? So we're going to be listing all the customer and ordering the results set by the last name in descending order. So we're going to have the order by clause and then you specify the column that you want to order by. So in this case, we're going to do last name. And then you can say SC for ascending, or if you want it in descending order, you say DE SC. So let's execute the statement, and you'll see that the dataset is ordered by the customer's last name. We could also order by the DOB. So we're going to be displaying all the customers and ordering the result set by the date of birth, right? So it's very easy to do, guys. What I'm going to change here is the last name to DOB. Now let's execute. And you can see it's ordered by the date of birth. So the oldest date of birth in this table is the 16th of April 2000, and the most recent is the 21st of November 2023. If you remove the DSC, the data will be ordered in ascending order by default. So let's execute. So you can see that the data was reordered. This may be a lot to digest in one lecture. So what I'm going to do is that I'm going to do a part 2 and continue in the next lecture. Let's say you wanted to list all the customers from the customer table whose first name starts with a S. How will you achieve this? Now, in order to achieve this, you will use the like statement combined with the wildcard operator, which is denoted by a percentage sign, right, to accomplish this task. So let's look at our first example. So what we're going to do now is that we're going to list all the customers with their first name starting with an S. So we're going to have our regular select statement, right? So we're going to have the select asterisk from customer, right? Then we're going to say where the field name that we want to filter on, which is the first name. And then we're going to use the like operator. So it's going to be, now we need to use the like clause. So it's like, right? And we need to combine it with the percentage sign. And this is always quoted in strings. So it's S, right? And the wildcard sign is after the S, meaning that means anything starting with S. So let's execute and see what our data set looks like. Here we can see that we got Stacy, Shane, Stacy, and Shane, right? So they have different last names and different ID numbers. So the position of the wildcard operator is very important in the like statement. Now let's look at another example. So let's list all the customers whose last name ends with ON, right? So we can pretty much copy and paste this for the syntax, right? Then we're going to make the modifications. So instead of first name, we're filtering on the last name. We're keeping the like operator, and this time it's ending with ON. So the wildcard operator should be at the beginning, right? So we're going to specify the wildcard and then specify the criteria after the wildcard. So let's execute this statement and it run. And for the result set, we got Jackson and Dixon. Now let's say we want to list all the customers whose last name contains an A. How will we go about this, right? So let's copy and paste the statement. So for the containing, that means anywhere the A appears in the name, we want it to be displayed. So whether it's at the beginning, in the middle, or even the end, we want it to be displayed. So to achieve this, right, what we are going to do is use two wildcard operators and change the criteria to what we want to achieve. So it's percentage sign, A, percentage sign. So anything that containing A will be displayed. So let's execute. Select run, and these are all the list of customers with last name containing an A. In this lesson, we're going to be taking a look at calculated columns. So far, all the columns that we have using our queries were predefined columns within our table. You can also generate columns on the fly. Now in the customer table, we have the date of birth column. But what if we're asked to find the age? How do we go about this, right? Well, you can calculate the age column on the fly. To achieve this, we'll be using the date function. So the date function takes three parameters. It takes a date part, which can be anything like, say, day, month, year, time, hours, minute, seconds, or even milliseconds. We have the start date and the end date. So to get the date of birth, we'll be using the date function to calculate the age. So the date part we're using is the year because we want to get the age in years, right? The start date is the date of birth field, and the get date is a function that returns the current date, right? So if we're supposed to do a select get date, it will return the current date, right? So let's select get date here. So this is the current date and time. So what the date diff is going to do is that it's going to subtract the end date from the start date to generate the age. And here we have an alias as age. So when we execute this, it should calculate the customer's age. So the ones here that are saying null are the customers that are in the table without a date of birth. So this is not really meaningful. So let's display the customer first name, last name, and date of birth along with their age. So let's execute the statement here. And this is more meaningful data. Now the age is definitely going to be 0 because the current here is 2023, which this course was done. So these dates are technically not valid because these are just demo dates, right? But if you scroll down, you see for Wilson Dixon, who was born on April 16, 2000, ages 23. So here you can see that it shows the age. If we were supposed to execute it without the alias, it will not show a column name. So let's execute this again. And it says no column name. So that is why we use the aliasing. Now let's look at another example using the cars table. So we're tasked here to display all cars, make, model, cost, along with its sales price. And we're given the GCT of 15%. So to find the sales price, we'll typically find the GCT of the price and then add it to the price of the car. So basically here we're saying 15% of the cost is whatever it works out to. Then we're adding it to the original cost to get the sales price. So it's make, model, the original cost. Then here we have the calculated column as sales price. So let's execute this. Now select run, and here you can see that we have the cost and sales price. Now if you look at the sales price, we have 6 decimal places. So this is not consistent with the cost. In order to achieve a level of consistency between the sales price and cost to have the same 2 decimal places, there are various ways we can achieve this. So I will be sharing 2 ways with you that you can use. We will be using the cast function as well as the convert function. So if you're totally new to what are functions, functional basically pre-packaged codes that carry out an operation for you. So it will basically have like a bunch of logic in it, right? That does all the work for you. So the first method we're going to be looking at is the cast method, right? So let's space this. So what we're going to be doing is casting all of this as a decimal. So it's cast, open bracket, then we need to say as, and then we're going to specify decimal. So the decimal data type accepts 2 parameters. So it accepts 2 parameters which determines the precision on the scale. So the precision is an integer representing the total number of digits allowed in the column. So if we're supposed to say 5 here, then only 5 digits is allowed in the result set. Now let's keep it at 5 for now, right? And the second parameter is the scale. It determines the number of decimal places, right? So let's set this to 2 and execute. So we need one more closing bracket, right? So now let's execute, and it failed. Arithmetic overflow error converted numeric data type to numeric, right? So this is because we're trying to display more values than what is allowed based upon what we set here. So to get the correct data, we specify a 6. So let's execute and select run. So this time our result was returned successfully. So what the cast function do is that it converts one data type to the other. So you could use it to convert a string data type to an integer, right? Now let's look at an example using the convert function. So let's copy and paste our original select statement. This time we'll be using the convert function, right? So we need to specify convert. It takes 2 parameters. So the first parameter is going to be the data type that you are converting to. So let's copy, paste this here, remove that bracket from there, and then we need to close the bracket. So let's execute this and select run. You can see that we achieve the same result. In the next lecture, we'll be taking a look at aggregations. In this lesson, we're going to be taking a look at aggregations. Aggregations are performed using aggregate functions like sum, average, count, min, and max. There are others, but we'll be just focusing on those in this lecture. It's very important to note that these functions operate on a set of values within a specific column or expression and return a single calculated value based on the data within the column. Now for this lesson, we're going to be using the card table to perform aggregation. So let's take a brief look at the data within the card table by doing a select all from the card table. So let's execute the statement here. And here, if you look at the cost column, you can see that we have a range of price. Now, let's say we want to find the average of a car. What we can do is that we can utilize the average aggregate function. Now, guys, these are very easy to use. So what you need to do is say select average, right? So it's AVG, and within that function, you're going to pass the column. So the column we are passing is cost. And then you specify from and the name of the table. So it's from car. So let's execute this statement. It run. Here we can see that the average is $3,200. Now if you look at the result set, the column is not named. So what we are going to do is use the alias which we learned in the previous lecture. So it's as average cost. So let's execute this again. So now you can see that we have a named column. Now let's explore the card table again. Now let's count all the records within the card table. So this time we're going to be counting on the primary key. So it's select the name of the function, which is count. Then we're going to pass in the chassis number as a parameter as total cars. Then we're going to say from car. Let's execute and it run. And here we can see that we have a total car of 8. Now please keep in mind, guys, that you can combine these with where clauses. So let's say we want to count all the undoes. Then we could modify the statement, or let's just copy and paste it and include a where clause. So it's where is equal to under. And here count all the cars that are under. You can also find the maximum price of a car in the car table. To achieve this, we use the max aggregate function. So let's copy and paste one of these select statement. So what we're finding is the max cost, right? So aggregate function here we're using is the max. The column we want to find the max on is the cost, and we're going to say as max cost. Now let's execute this, select run, and the max cost is $6,040. You can also find the min. So instead of using the max function, you use the min function, right? So let's paste. So we're going to change max to min. We're going to alias the column as min cost. So when we execute this, we get the minimum cost for a car, which is $2,000. We can also do a total by using the sum function, right? So let's copy and paste this. So we're going to change the function from min, and we're going to alias it as sum of all costs. Now let's execute this. And when all of the values are added up, we get $25,600. Now these aggregate functions can be combined with the group by clause. This will group data based on certain columns and perform aggregation within the groups. Let's say we wanted to see the average price of a car for each make, right? We could achieve this by performing a group by on the make column. So we would write our regular select statement saying select average, right? So it's AVG. We're going to pass a cost column to the function. We're going to alias it as usual and call it average price. So I'm just going to shorten it as AVG price for now. And then we have from car. And then we have the group by clause, right? So it's group by and the column that you want to group by. So in this case, it's going to be the make column. So it's going to be grouping by each make. So let's execute this and see what our result look like. So here we can see that we have some results set. However, this is not really meaningful because we do not know which make it is associated with. Now we can add the make column as part of the result set. So let's add the make and put the comma. Now let's re-execute and select run. Now here you can see that we have the average price for each make. Now one thing to note there is that apart from the aggregated column, right, or calculated column, we can only have columns that are a part of the group by in the select statement. So if we had said we want to show the model as well, we'll get an error for this result. So let's run this. You can see that car model is invalid in the select list because it is not contained in either an aggregate function or the group by clause. So any columns that you want to show in your select statement, it has to be a part of the group by clause. We can also limit our aggregation by using the having result. Now let's say we wanted to see only cars with an average price that is greater than or equal to 3,000. Here we can introduce the having clause. So the statement will pretty much remain the same. So let's copy and paste. And then here we're going to see having. We're going to have to calculate the average again. So let's copy. And then we're going to say greater than or equal to 3,000. Now let's execute this and select run. So my signs are incorrect, so it's the other way around. Let's execute again. And here we get the result set. Only the makes that have an average price of 3,000 or more are displayed. So guys, again, once you understand the basic concept, you can write more advanced queries. In the next lecture, we're going to be taking a look at the join clause. In this lesson, we're going to be taking a look at the join statement. Join statements gives you the ability to use a select query to view information from two or more tables at the same time. So we're going to be taking a look at one of the most. So for this course, we're just going to be taking a look at one of the most common one, which is the inner join. You also have joins like the outer join and the right join. You can do additional research on those. So this is the general syntax for the join statement, right? So here we have table A, table B, and table C. So whenever you're joining tables, you must join on the common fields within both tables. Now it doesn't have to be the exact name because you can always name a field whatever you like. But basically the data set must be the same. And this is basically how you will join another table in the same query. So here I have an insert statement to insert some data in the address field, which I executed, right? So if we select address, it will return this data set here. And if we select customer, it will also return this data set. So let's execute them all at once. So you can use the sidebar to your far right to scroll, or you can adjust the window height. So let's say we wanted to find out customer's Marcos address. We could simply look at the customer table here and identify his ID, and then we look at the data set for the address column and identify the customer ID. So here we are making the relationship to know that this customer number is for Marco. That means Marco's address is 15 ABC, New York, right? USA. But to achieve this, we basically had to execute two queries. We can achieve this in one statement by joining the tables. So let's look at our syntax, right? We're going to select the fields names that we want, right, from the first table, and then we're going to join the second table on the common field. So the first table here can be customer or address, right? So we're going to go with customer. So let's grab this part of the syntax. So we're going to be replacing the first table. We want the customer name. I'll get back to this table name later, so I'm going to remove it. So we want to display the customer first name, last name, their street address, as well as the country in which they live. So we have all the columns that we need. However, if we execute this, the select statement will fail because the street and the country columns are not a part of the customer table. So we need to join the address table, right? So we're going to say inner join, or you could just use the join keyword, right? So we're using the inner join for now. So now we need to specify the second table name. So we're inner joining customer and address. Now we need to identify the common field for both tables, right? So from the customer, it's customer ID, and from the address table, it's going to be the customer ID as well. So to get rid of the address being shown in blue, we can put a square bracket around it, right? So what we're doing here is basically joining the primary key and foreign key relationship. So let's execute. Now here we have the data being returned in one result set. Now let's copy this and paste. Now let's say you were asked to display the customer ID. Well, the most obvious thing to do is copy the customer ID and paste it or type it out, right? But this is not going to work. So let's execute. Ambiguous column name customer ID. This is because address and customer both have a common column called customer ID. So how does the query know which one to display? It doesn't. That's why it failed. So this is where you specify the table name of the column that you want to display. So if we say customer.customer ID, then that will take care of the ambiguity, because now SQL Server knows which one to display. So when we execute this, it did not complain. You can also use aliases for your table names. So let's copy and paste this. So for customer, we could shorten it and say C, and for address, we could say A. However, we need to change this. So instead of saying customer ID, we could say C.ID, and instead of saying address ID, we could say A.customer ID. And same thing in the select statement. We could say C customer ID. So when we execute this statement, we should get the same result. You can also use the where clause when you're joining tables. So let's say we wanted to display all the customers who live in the USA. We could do a filter on the country column. So let's copy and paste the statement. So we're going to include our where clause, and it's where country is equal to USA. Let's execute this statement. And here you can see that we have only customers who lives in the USA. In the next lecture, we'll be taking a look at the update statement. In this lesson, we're going to be taking a look at the update statement. Now, the update statement allows you to make modification or changes to existing data within your database. So for example, if you have misspelled a name, you want to make some correction to some data, then the update statement is what you use to achieve this. So here we have the customer table with this sample data set, right? And we're going to be performing several updates on this table. When you're updating data, when you do not specify a where clause, that means you're updating all the data for that column. So for example here, when I run this update statement, it will set all the date of birth to 1992, the 2nd of February, right? So let's execute this. Now let's query the customer table. So here you can see that all date of births were updated. Now in some situation, you may need this, but not in all cases, right? So it's good that when you're doing updates, you utilize a where clause. So you can update a group of records by using the where clause, right? So for example, for every customer with the last name Jackson, we're going to update it to Nelson, right? So you can see that we have about 4 Jacksons in the database and we want to change it to Nelson. So then when we execute this and it run, we have 4 rows affected. So let's query the customer table again, select run, and the Jacksons were updated to Nelsons. Now to update a specific record, you know that you use your primary key or your unique key. So in this case, it's a customer ID, and here James does not have a last name. So we're going to be setting a last name for James by specifying his customer ID. So let's update, execute, and view the result again. So here we can see that James' record was successfully updated. You can also update multiple columns within the same update statement. So I could do a last name, first name, and date of birth within a single statement. So here I'm going to update the customer 7 again. So instead of saying Mason, I'm just going to say Mason 1 for simplicity and set the first name to Kevin, right? So the current first name is James And when we execute this, one row will be updated with both the first and last name. So to recap, the update statement allows you to make changes to existing data, and you have to be careful with your update statement. Always ensure that if required, you use a where clause to filter the amount of data that you want to update. In the next lesson, we'll be taking a look at the delete statement. In this lesson, guys, we'll be taking a look at the delete statement. The delete from statement is used to delete an entire row from a table. You can delete a row at a time, specifying the primary key, or you could delete a group by specifying whatever criteria you need and leaving off the primary key, or you could just delete everything. So here I'm using a backup of the customer table, and I'm going to delete the customer ID that is equal to 7. So when I execute this, only one record will be affected. Now, executing the delete from statement without specifying a where clause will delete all the records in the table. So when I execute this statement, all the records will be deleted. So here you can see that 5 rows was affected. So if I do a select from, no record will be returned.